Good morning, AP Statistics students. Going to look at 2014 investigative task. Number 6, 2014, about FCR, fuel consumption rate. So a lot of reading in this question. That's not uncommon in investigative tasks. Got to get your read on. And we got a lot of graphs, a lot of stuff going on here. Graph 1, we have the length of a car, 66 cars, the length of a car compared to its fuel consumption rate. And we have a point kind of right in the center labeled A. Be a Jamal. Jamal did a little regression output. And question A. Typically on the investigative task, question A is something that we have talked about and learned in AP Stats. The parts after that might be trying to take you down a path, learn something new, observe something new, a little bit beyond our curriculum, or maybe stuff we've learned but in a new context. So the point labeled A represents one car with a length of 175 and FCR 5.88. Calculate the residual and interpret the residual. If you haven't had a chance to try this question on your own, I'd recommend pausing or stopping the video and trying it on your own. Take about 20 to 25 minutes. The recommendation is 25 minutes for the investigative task. But see what you can do. So first things first, the formula for a residual. The formula for a residual is AP statistics, A minus B, which is the actual Y minus the predicted Y. So we need to find the prediction. To find the prediction, we have our regression equation right here. We're told the length is 175, so we're going to plug that in right here, and that would be our predicted FCR. And our predicted FCR, when you plug that value in, is 4.925. Puts 175 in right there. It's kind of hard to read, but 175 for length. So our residual would be the actual FCR. The actual FCR is 5.88. The predicted FCR is 4.925. And we get a residual of 0.955. You'll definitely want to show on your response, you want to show yourself plugging in 175 into this equation for length. Sadly, a lot of students stop there and got a partial. You notice what they neglected to do. They have not interpreted, or we have not interpreted this yet. So to interpret a residual, note that it's positive. And a positive residual means if this is your regression line and the point is up here, then this distance, this vertical distance, is a positive residual. So that means something like for a car with 175-inch length, the least squares regression line under-predicted. The line is beneath the point. The line under-predicted the FCR by 0.955. That's one way that you could interpret it, but there's another way. Rather than using the under-predicted language, you could say that the observed FCR is 0.955 above the predicted FCR. Make sure you use context. Should be mentioning the length of the car and the FCR. Make sure that you identify either that the point is above the prediction or that the line is under the point. You need the magnitude and the direction. It's like a vector. Magnitude, the value itself, and the direction, that it's a positive direction. So if you can get the interpretation correct and the value correct, then that would be an E. So 1 out of 4 points on the investigative task is pretty good. The average on this was a little bit more than 1, so hopefully we can get a little bit more before we close it up. So let's look at part B. We have a lot more reading here, and it's very important to read and try to make sense of what's going on. So it says here he wants to improve the original model. So he knows it's possible to predict a response using more than one explanatory variable. What this is called is multiple regression. In our course, we only do simple linear regression. We just try to predict things with one variable, one explanatory variable, but he's going to try to use multiple explanatory variables, which makes sense. It would make sense, if you're trying to predict how well someone's going to do in the class. Maybe you could use their GPA to predict, but you can use other variables as well. Maybe you could use their previous math class to predict how they're going to do. Maybe you could use their test scores to predict how they're going to do on a big high-stakes test. You can use multiple variables to predict. In this context, we'd like to predict the fuel consumption rate of cars. Maybe it's not just the length of the car, maybe it's something else. So he thinks he can improve his model by, get rid of this a little bit so I can read, by including a second explanatory variable in addition to length. So he's considering engine size, and he's considering the wheelbase, the length between the axles. So maybe the weight of the engine would affect fuel consumption. That makes sense. Maybe maybe the wheelbase, the length between the axles, maybe that would affect fuel consumption. So what we have here are two scatter plots. It's really important to notice the axes here. For these two scatter plots, here's the engine size as another explanatory variable, and here's wheelbase as another explanatory variable. And then notice that what is being graphed are the leftovers, the residuals from our first regression. Residuals from regression of FCR and length. So we have two different scatter plots here, and then part B is basically trying to encourage us and get us used to kind of what's going on in these graphs. So in part B, number 1, it says, in graph 2, so the engine size on the left, there's a point A that corresponds to the original point A that we had in graph 1. And then they give us information on that point A. And then we're asked to circle the point on graph 3 that corresponds to the car represented by point A. So this engine size 3.6, that's the engine size of point A. This value is approximately that 0.955 that we got from question part A. But we're asked on this second graph to circle a point, and we have lots of options. There's 66 points, I believe 66. And we have to circle one, so we have a 1 in 66 chance of guessing right. So rather than guessing, since this is wheelbase, and the car, the point we're trying to circle, has a wheelbase of 93. So it looks like here's 93, and we have 3 possibilities. This top one up here, this one, or this one. Maybe I'll highlight them. I don't want to circle them yet because I don't want to confuse anybody. So we have this one, and this one. So which of those 3 would be corresponding to this point A? Well, it has an engine size of 3.6, but there's no engine size on this graph. But we do know the residual that we got from part A. So if you miscalculated the residual in part A, you could still recoup maybe your answer here. But the residual we got from part A was the residual from our regression of FCR based on length. So which of these 3 points have a residual of 0.955? It would be this point. So the scoring on this part B, if you were able to get at least that point correct, then you would get a partial so far. You have to answer the next part correctly to get a full, essentially correct. So let's look at the next part. Part B, II, says there's a point on the graph on the right, labeled B. It's very close to the horizontal line. What does this indicate about the FCR of the car represented by point B? So what this horizontal line is representing is that from the original graph, the FCR was very close to prediction using the length of the car to make predictions. So this point B is very close to that. So we'd want to say something like the car represented by point B has an FCR that is very close to the least squares regression line using length. So notice I've mentioned that it's very close. It has a small residual. It's slightly positive, slightly above the line. And notice I've mentioned the FCR and the length. So if you could get both part I and double I correct, then that would be essentially correct. If you did that so far, you'd be, if you got an E on the first and E on the second, you'd be a 2 out of 4 on the investigative task, which is excellent. Let's look at part C. Write a few sentences to compare the association between the variables in graph 2 and the association between the variables in graph 3. So looking at these graphs, what associations can we identify? Well, it looks like graph 2, the scatter plot is going uphill, so a positive direction, whereas in graph 3 it is not so much. So this, we could say there's a positive association between engine size and the leftover residuals. Positive. This we could say it's roughly linear. This one is appears to be no association and not linear, no form basically. And then as for strength, the graph 2 is more strong of an association than this graph using wheelbase. So to get an E on part 3, you had to do 3 things. You had to compare the direction and the form. Number 2, you had to talk about the strength of the association. And then number 3, you actually had to compare them. You shouldn't just list them, but say which one's more strong, more positive, more linear than the other. So if you got all 3 of those, then that would be essentially correct, and you'd be now at a 3 out of 4. So this was kind of a nice way. Basically, we've done this before. This is just doing DOFs, direction, outlier, form, and strengths. We skip the outlier, but we have direction, form, and strength. And we're doing this kind of in a new context. We're comparing 2 different graphs with this, describing the association with DOFs. And then on to our last part. If anything is investigative, it would be part D. Jamal wants to predict FCR using length and one other variable, engine size or wheelbase. Based on your response in C, this is incredibly important. Based on your response in C, which variable, engine size or wheelbase, should Jamal use in addition to length if he wants to improve the prediction? Explain why you chose that variable. If If you remember in part C, we just said that this graph on the left, that this has a stronger association than this graph. So we should choose engine size, because engine size does a better job at explaining the leftover association that there is with FCR. Wheelbase, however, using wheelbase doesn't really add anything in explaining the leftover pattern or leftover association between FCR on length. So the common mistake that students made here is they thought that these were residual plots, but they are not plots of the residuals. We're not plotting wheelbase versus the residual of FCR versus wheelbase. We're taking the leftover residuals and having that as a separate data point, and then comparing engine size to those residuals of FCR on length. So what a lot of students did, they select graph 3 and say, well, since there's random scatter, we want that because in a residual plot you want random scatter. That is not what this question's getting at. This question is getting at that there is this pattern left over in the residual plot that engine size does a much better job explaining. So engines that are smaller engines, there's the residuals are below the line. Engines that are large engines, the residuals are above the line. Whereas on wheelbase, whether the engine or whether the wheelbase is small or large, it doesn't really do a good job at predicting where the residuals will fall. So to get essentially correct, you would have to say engine size because of the strong association. And to explain why that's good, you would have to mention something about it's explaining the pattern or explaining the leftover variability that was not explained when we used only length as our explanatory variable. So that fourth part was also worth an E. Very difficult on this one to get an E on the last part, and that's not uncommon on investigative tasks. But I hope you were able to use your answer in part C. If there's anything we can learn from this, if I were to give you a couple takeaways, you probably won't be asked multiple regression on your AP exam. But the two main takeaways, I would say. Takeaway number 1, make sure you know how to calculate and interpret a residual. That is something that we've done that can obviously appear on future free response questions, not just investigative tasks. But also, a really important part is if you're told, as you often are in investigative tasks, to answer your question based on your response on part C, I would definitely go back, look at part C, and use what you said in part C to answer this question. And I think if you did that, if you were cognizant of that, then you would have said, oh, in part C I was really talking up on this engine size. I really liked engine size as positive association, it's stronger, etc. So maybe I should say engine size here, and then go from there. Thank you for watching this video, and good luck on your investigative task.